Hey guys, Rahul here. I'm audible to all of you. I'm audible to all of you. All right. So welcome to the session, and I hope all of you guys are doing good. So in this next 1 hour of session, we are going to talk about the concept of k-means clustering. So basically, it's an unsupervised way of machine learning, and we'll first understand where it can be used, and then we'll go ahead and talk about brief of the k-means clustering. For example, let's say I have a data set where I have the salary and the spending score. Now, what we want is we want to cluster our customers based on the salary and the spending score. Why we want to cluster? For example, let's say I have various different customers based on the salary and the spending score. We have these customers with low salary, low spending score. We have these customers with low salary, high spending score. We have these customers with high salary, high spending score. And we have these customers with high salary, low spending score. And finally, we have the average type of customers as well. So these are the different types of customers which I have. And let's say I am coming up with a very expensive product. Which type of customer we will market? Obviously, we will first try to market these folks. The reason being they have the high salary and high spending score. Because of that, we will go ahead and market these folks because my product which I am trying to sell is an expensive product. Maybe I can try these folks as well because their salary is low, but their spending score is high. Maybe they can also purchase this particular product as well. So suppose my marketing budget or my campaign budget is less. So I have to create these type of clusters on my data set so that I can pinpoint my exact audiences. I can pinpoint my exact audiences. And that's the reason we use this k-means clustering or any clustering technique, because what we want is we want to actually target the exact audience so that I can reduce my budget of the marketing. If there is no problem in the budget, I can spend a lot of money on the marketing. In that case, I may not require more number of clusters because I will actually market the entire audiences because my marketing budget is good. But as my marketing budget is getting lesser and lesser, in that case, I may have to go ahead and increase the number of clusters so that I can actually get the customers which are high probability that they will purchase the product. For example, let's say I'm coming up with a Python course. Now I have various different types of customers. Maybe students from the mechanical background, students from the medical background, students from the IT and computers background, students from the civil background, students from the BCom background. If my marketing budget is good, in that case, I can target everyone. But if my marketing budget is not good, in that case, I will pinpoint to the exact audiences. In this scenario, IT and computer people, I will target them because they are the one who are who are having high probability that they will purchase the product. So that is the whole idea why we require clusterings, so that we can segregate the data based on the similarity. Now you may ask that this can be done through Excel also. We can apply the filter and all those things we can do. Absolutely. But when think about when we have the high dimensions. As of now, I took only salary and the spending score. What if I will have salary, spending score, and various different fields, gender, age, and whatnot? In that case, it is very difficult for me to generate a clusters. And that's the reason we require machine's help. And there, this machine learning algorithm, which is comes under unsupervised machine learning, known as clustering, comes into picture. It is known as unsupervised machine learning technique because I don't have anything to supervise. For example, let's say there is a guy A. I am putting in this cluster. There is a guy B. I am putting in this cluster. So why are you putting here in A here and B here? Because he is having the high salary and the spending score. Now, whether he actually belongs to A, like he actually belongs to this cluster or not, I cannot check that. It is purely based on their features. We are clustering the data. I cannot have any second check whether the cluster which we have created is correct or not. However, in the supervised machine learning technique, we have the labeled data. So there I know that, for example, let's say I want to predict whether this customer will purchase the product or not. Now we are training our data on the actual data where I also know that whether the customer purchased the product or not. So I can check what my model is predicting and what my actual data is. For example, my model says that he will purchase the product, but my actual data says that he will not or he did not because it's old data. So obviously it is not meeting. So that means the prediction is wrong. However, in the cluster, it is purely based on the similarity. We are segregating the data out here. Now there are various different algorithms which we have to solve the cluster problem. One is k-means clustering. One of the very powerful and very popular algorithm which we have. Tools like Tableau also uses this at the back end. Second type of clustering we have is hierarchical clustering. We have DB scan clustering. These are the quite famous clustering techniques which we have. K-means is obviously be the best because performance wise, it is much faster as compared to the rest of the two clusters. Performance as in the speed, the processing power I'm talking about, not the accuracy. Accuracy wise, obviously it is good, but others are also doing a good job. But performance wise, the speed of the algorithm is much faster. That's why the tools like Tableau also uses this at the back end. So in this particular discussion, we'll quickly have a discussion about the k-means. Again, it's a big subject, but in this limited period of time, I will go ahead and try to give you the brief idea. Also, if you are interested to know more about this, you can fill up this form. So I'm pinging you on the chat window. So we have the entire end-to-end data science program for 9 months. So you can fill up this form and you can show your interest there. So here is the data set which we have. In this particular data set, we have the customer name, we have the customer ID, we have the customer gender, we have the annual income, we have the age, and we have the spending score. Now what we want is we want to create a cluster based on these two fields, that is annual income and spending score. Now how to go about it? How my k-means algorithm works on it. So first of all, I want to know how many clusters I have to create. As of now, either I can ask machine that create 3 clusters, 4 clusters, 5 clusters randomly, or I can go with some smart way. I can ask machine that how many clusters we can go for. So we can go with some smart way also. So we'll go with the smart way. We'll try to understand how many clusters is the best number of clusters. And for that, there is a concept of elbow method. There is a concept of elbow method, which will help me understand how many clusters are the best. By the help of machine's help, we are actually going to decide that. I'll open up one PPT to have a bit of intuitive understanding about this particular concept. So we are talking about k-means clustering. So let's talk about it and how it works. So first of all, I want to decide how many clusters are the best number of clusters we have. So here is the technique which will help me to decide the number of clusters. So in this data set, what we will do is machine will generate a random centroid. Machine will generate a random point in this particular data. Here is the random point which machine generated. From that data, I will find the distance of all the points with that point. I will calculate the distance. Now, how the distance gets calculated? Let's try to understand that. It's come from the mathematics. For example, there is a guy with age of 21 and salary of 21,000. There is a guy with age of 35 and salary of 35,000. So this is the guy which is 21,000, and this is the guy which is 35,000. So here we will have to find this distance, the distance between these 2 points. This is my x1, this is my x2, this is my y1, this is my y2. I want to find this hypotenuse, Pythagoras theorem, which is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is my distance d, also known as Euclidean distance. Euclidean distance. One problem is this with this data is my age is 21 and 35. Both are in years, year square, plus let's say salary is in dollars. So it's dollar square. So I am actually adding year square plus dollar square, which is wrong, obviously, because both are different units. Secondly, my year is very small number. 35 minus 21 is 14 square. However, 35,000 minus 21,000 is 14,000 square. So if I get the distance, my distance will be approximately 14,000. Because this is 14,000 square plus very small number of 14 square. Approximately 14,000 will be the distance. That means your salary is dominating your age. That is again a problem. So to take care of that problem, there is a concept of feature scaling. What feature scaling does is basically it tries to make your data in a same scale. There are various different techniques, which again we are covering in the main curriculum. You can fill up the form for the same. But one of the technique is known as standardization, which is very popular technique. The formula for standardization is, let's say x new is equal to xi minus x mean or mu x upon standard deviation of x. The unit of this is, for example, we are talking about age. So this is age, that is years. And this also is years. So years by years is coming out to be unitless. Same goes with the dollar as well. Here the value will vary from -3 to +3 for age as well as for the salary also, -3 to +3. So we are making the data in the same scale and we are making the data unitless. In Python, we just have to call one package and that will do the needful. Where xi is my original value, mu(x) is the mean of your age or salary. This is sigma x is my standard deviation of age or salary. Standard deviation is nothing but the spread of the data. It's a measure of spread. This is the mean measure of central tendency. Again, we are covering that more in the, because it's a big subject, as I mentioned, it's not 1 hour job. So we are covering more in the detailed curriculum. So now here we are finding the distances and we are calculating these distances. We are summing up these distances. And here we are creating one more chart, which is gonna help me understand if you are creating one big cluster, what is the Euclidean distance in the y-axis. Here my x-axis is one cluster, my y-axis is Euclidean distance. So how much distance you got here is what we have put here with one cluster. Same way, it will generate two centroids. My machine will generate two random centroids. It will find the distance of those two random centroids with all the points in the data set. And these are the points, let's say, near to yellow centroid, and these are the points near to green centroid. In that case, what will happen? It will just sum it up, the distance covered from the green centroid and the distance taken by the yellow centroid will sum it up and we can put it in the chart here. Obviously, that distance will be a bit lower than the previous distance which we calculated with the single cluster. Same process will go on and on, 3 clusters, 4 clusters, 5 clusters, and so on. You can see that at the point number 3, after that, your distance is not reducing much. It's very much static almost. It's going, what do you say? It's going down very slowly. It's not gradual decrease. So this is my ideal number of clusters. 3 are my ideal number of clusters. So basically in my data set, I should have 3 clusters is what my machine is saying. So this process is known as elbow method. I'll show you that in the picture as well. I'll show you in the coding as well how it works. It will generate a chart like this. You can see that it is generating a chart like this. And you can see here is the point. After that, the reduction in the distance is not much. So the ideal number of cluster will be 3. So that my machine is helping to decide that how many clusters are the best number of clusters in my data set. So here, once we got the idea that, okay, 3 clusters are the best number of clusters, then I will ask machine to go ahead and create 3 clusters. So once we know, so this is all things we have discussed already. So we decided 3 are the best number of clusters. So now in this data, what happens is that we will go ahead and create 3 random centroids. We are going to create 3 random centroids. The reason is because my machine told that 3 are the ideal number of clusters which we can have. That machine gave us the understanding. So now what I will do is I'll go ahead and basically create 3 random centroids. My machine will create 3 random centroids. Once that is done, what will happen? I will find the distance of these centroids with all the points again. I'll find the distance of these points with all the points. Let's say these are the points near to blue centroid. These are the points near to yellow centroid. And these are the points near to orange centroid. Because again, we are finding the distance, right? We are finding the distance and we are actually calculating the distance of these 3 new centroids with all the points and found out that this 8 points are near to this blue centroid, these 4 points near to yellow centroid, and these 4 points are near to green centroid. These are the 3 centroids which machine randomly created. This centroid is actually nothing but the center point, but here machine randomly created the centers. So obviously, as I know that these are the 8 points near to this blue centroid, my machine will recalculate the centroid again based on these 8 points. So once my machine will recalculate the centers, there are chances that my centroid will shift. There are chances that my centroid will shift because my center point will be changing because initial centroid was random. Now, once that is done, I will recalculate the distance of the new centroid with all the data points. And during this process, there are chances that some of the points will shift from one centroid to the another centroid. Some of the points will shift to one centroid to another centroid. Like these 2 points earlier belongs to blue centroid, but now it is belonging to green. So now this process will go on and on because now again my centroid will change. Again, the points will shift. This process will go on and on till the time the reduction in the points reduced. And then that is my final number of clusters. Once the shifting of the point reduced, my final cluster will get created. So that is the whole idea based on similarity, based on the distances. It's finding the distances and creating a group. That is the whole idea here. Now what we'll do is we'll see this in action using Python. So I'll open up Python here. So here is my Jupyter notebook. I will import this data set which I have in my machine and it is present in this working directory. So let me open up that. Here we go. So I'll go ahead and import os.chdr. It's helping me to change the working directory because I want to ask Python that read the file from this location. Import pandas as PD. So pandas is again very powerful package to read the data coming from Excel files, CSV files, and various different file systems, which is the structured data basically. So here is my data set, which I am reading. And here is my data, which we actually read from the CSV file because the file was CSV. The file which we had in the source was the CSV file, comma separated values file. So I have read the data. I have read the data here. Now my interest is that I just want annual income and spending score to go ahead and create the cluster. So I need only these 2 columns. I don't want the rest of the columns as of now. Obviously we can take that, but I am as of now not taking it. I'm just going with these 2 columns to create the clusters. So I will just choose these 2 columns. But before that, I will just go ahead and create one data visualization to understand how things are. Whether we see some clusters, whether the data is having some clusters, we'll try to see that. So we will use one of the packages, which is again very nice package called cbon. Import cbon as SNS. And here sns.lmplot. Lmplot is basically the linear model plot, which is actually nothing but a scatter plot. When we have the 2 numbers, we prefer to create a scatter plot. You will understand once I create that. X is equal to and Y is equal to. So my x-axis, what I want is the annual income. I'm taking this column. And the y-axis which I want is the spending score, which is this one. You can see that you are going to get some chart here. You'll get one line also. I'll remove that line. It's a regression line, which we don't require anymore as of now. It's taking a bit of time. So here is my data set and here is my visualization. And you can see that here it is actually looking very nice clusters. I see these are the people with average salary, average spending score. These are the people with high salary, low spending score. These are the people with low salary, low spending score. These are the people with low salary, high spending score. And these are the people with high salary, high spending score. In the real time, you will not get this type of beautiful clusters. This is totally meant for the training purposes. That's why you can see it's looking very nice clustered data. So as per me, 5 clusters is the best number of clusters. But I will ask machine. I will ask machine that how many clusters can be the best number of clusters. So I will go ahead and first of all, from my data set, I will take only 2 columns, that is annual income and spending score. Indexation starts with 0 in Python. So here we have this data and this data, which is basically your annual income and spending score. So now this column 3 colon 5. So what we are doing is we are picking up the third and the fourth column, because if you go back to the data set here, indexation in Python starts with 0. So this is my 0th column, 1, 2, 3, 4. So when you are writing 3 colon 5, 5 will not participate. So 3 and 4 will participate. You can see column number 3 and column number 4 is coming in. Dot values. It is converting it to an array. And this is my X, that is the input, which I am going to use to create the cluster. Now, once that is done, what I will do is I'll go back and try to check how many clusters are the best number of clusters in my data set. So from sklearn. So sklearn is a very powerful machine learning package in Python. So you can check here. There's a very nice documentation available. Sklearn means. So here you can see that we have the entire documentation. These are the package. This is the package which you have to call. How many clusters you want to create. There is a technique to initialize the centroids. Again, that we are covering more in detail in our curriculum, how it works. So as of now, I'm just executing this code. Initialization technique is basically nothing but how to initialize the clusters, right? How to initialize the clusters or the centroids basically in the data set. So here we will go ahead and first of all decide how many clusters are the best number of clusters. So I want to check with machine. So from sklearn.clusters, import k-means cluster. I'm creating one empty list, WCSS. I'm giving an empty list. And now I will apply a for loop. For I'll explain this thing. For I in range 1, 11, k-means is equal to k-means n clusters is equal to I. Init is equal to k-means plus plus. Means dot fit x WCSS dot append k-means dot inertia. K-means. Okay. Let's understand this code. What's going on? So here what we are doing is I'm asking machine to generate 10 clusters. If you guys remember from that PPT, what they were doing, it is creating, if you see this slide, 1 cluster, 2 cluster, 3 cluster, 4 cluster, 5 cluster, and so on. Same way I asked machine here in my example that generate 10 clusters from cluster number 1 till cluster number 10. 11 will not participate. And then it is calculating the distance with I. It's a for loop. So I will be 1 first of all, then 2, then 3, then 4 up till 10. Initializing the cluster, putting the data in that cluster, basically in that, what do you say? Putting the data in the model k-means and calculating the distance. And in this WCSS, we are appending the distance. When the cluster is 1, what is the distance? When the cluster is 2, what is the distance? When the cluster is 3, what is the distance? And so on. So here, if you see the WCSS out here, you can see that we have the list of distances coming in. And now I want to plot this distances in my chart to see what is the elbow, where is the elbow. There is one more package for data visualization called Matplotlib. So import Matplotlib dot pyplot as plt. plt.plot, I want to plot in my x-axis the range from 1 to 11, number of clusters basically, and my y-axis will be WCSS, and here we go. Here is the data which we are getting in. Here is the chart, and you can see that after cluster number 5, the distance is not reducing much. And that is what we have discussed. That is what we have seen in my data set also. That 5 clusters looks like an interesting clusters, giving me a good data clustering. And that is what we have seen in this plot as well. So 5 clusters are the best number of clusters. Once we know that, I will go ahead and I will create the clusters again. This time with 5, because we decided that 5 is the best. So here I am going to run my k-means algorithm again, where n clusters this time gonna be 5. I want to initialize using k-means plus plus. K-means plus plus is a technique to generate the centroids. It's again a bit of mathematics, which I'm not covering as of now. K-means, and then y k-means is equal to k-means dot fit and predict based on your data set X. Now here I got my clusters. These are the different clusters starting from 0 till 4. Cluster number 0 is 1 cluster, cluster number 1 is 1 cluster, cluster number 2 is one of the clusters, cluster number 3 is one of the clusters, cluster number 4 is one of the clusters. I will go ahead and join these clusters with my original data set. That means if you see the total number of records out here, we have total 200 records. and in my data set as well, there are 200 records. Actually, my data set which we have is this, and the cluster which we just created is YK means. So basically, my first customer is belonging to cluster number 4. My second customer belonging to cluster number 2. My third customer belonging to cluster number 4 again, and so on. So I want to somehow join this data with this data so that I can understand what's going on. So here what I will do is I will do a concat pd.concat. Pd is again the pandas package which we imported. I want to concat my data set with pd.dataframe. I am converting my this ykme. It's an array. It's a array. I want to convert it to data frame. So yk means, here we go, and bracket join, and here I will write axis is equal to 1. Axis is equal to 1 is nothing but your row by row join. So basically, my first row of the data set, joins with the first row of the y. You can see here 4. It's a one-to-one index join basically. It's an index join. 0th index join with 0th index and so on. Once that is done, I have a cluster number with me. I know cluster number 4 is low salary, low spending score. Cluster number 2 is low salary, high spending score. Cluster number 1 is high salary, high spending score. Cluster number 3 is high salary, low spending score. So obviously the cluster number 0 left. Cluster number 0 will be what? It's low salary, low spending is already there. Then low salary, high spending score is also there. High salary, high spending score is also there. And high salary, low spending score is also there. That means average salary, average spending score is cluster number 0. So now what I will do is I will store this output in one of the variables. And now in this output, what I will do, I'll first of all rename this 0. I'll make it as cluster. I'll name it as cluster. So output dot rename. I want to rename the columns, where 0 is nothing but clusters. So you can see I have renamed this column, and I will overwrite my existing data frame. So here is the output which we have. Now what I want is here, I want to make it more intuitive. As of now, cluster number 4, I have to look at the data and I have to see, okay, the salary is low, spending score is also low. That means it's a low salary, low spending score type of data. Same way, if we go to cluster number 2, I have to look at the data. It's low salary and high spending score type of data. So it's very difficult for me to understand. Rather than making this 4 to something else, like as of now it is 4, I will write it. I want to give the value to it. For example, cluster number 4 is what? Low salary, low spending score. Cluster number 2 is what? Low salary, high spending score. Cluster number 3 is what? High salary, low spending score. Cluster number 1 is what? High salary, high spending score. And cluster number 0 will be what? Average salary, average spending score. So rather than having 4, 3, 2, 1, 0 and all those things, I'll give the name to it so that end user will go ahead and able to understand it quite clearly. So I will go and modify this. I'll say here in my data frame, there is a column called cluster. There's a column called cluster. I want to map. What I want is, if I see number 4, then make it as LS, low salary, low spending score. When I am seeing cluster number 2, make it as LSHS, low salary, high spending score. Third is high salary, low spending score. Fourth, which is first actually, it is high salary, high spending score. And finally, 0 is average salary, average spending score. And now what I will do, I will override this. I will override this on the same column, output clusters is equal to. And now you will see the magic. The magic is you have the cluster names as well. Now it's very easy for me to understand which customer are of which type. And I can very well export. I will very well export this data to maybe a CSV or an Excel format. Let's say output.csv. And here we go. The data is getting stored in the current working directory. My current working directory is here. And here you can see that output.csv on the 9th of December 1546 got created. Let me open up. Once you open it up, you can see the clusters with you. Perfect. And now let's say I am coming up with very expensive product. I know that people with high salary, high spending score will purchase the product. So these are the customers which I can target. So straight away with the machine's help, I got the output and I can go ahead and target these customers. Rather than calling all the 200 customers, I got the set of around 39 customers and I will market these 39 customers. So that is the power which we are getting. Again, we took a very small data set, but think of we have a huge data. I have worked for various companies where I have solved the problem statement with like hundreds and hundreds of columns. So at that point in time, this particular technique is quite beneficial. At the end, we can go ahead and create the visual. We can try to basically create the visualization on the clusters, how it looks like. So we'll go back. And now I will use the Matplotlib and I will create a cluster in the Matplotlib using Matplotlib. plt.scatter. I will use the X. X is nothing but your original array, which we created here, X. The first column of X or the 0th index of X is salary. And this is my spending score. So this is my index number 0. This is my index number 1. So I will go ahead and create the plot for cluster number 0. For 0th column, X, Y, K means 0, 1. S is equal to 100. I'll explain this code. C is equal to red. So basically here are the points which are the cluster number 1. Cluster number 1 is average salary, average spending score. You can see you are getting this type of, you see here, vertical dots are there. This is exactly the points which we have seen here. So as of now, it is only storing the data or visualizing the data for cluster number 0. X is my salary, Y is my spending score. This is my X axis, this is my Y axis, right? So this is my 0th column, that is the salary, and my first column is the spending score. My X axis is salary, my Y axis is spending score. Now the same thing I will do for my second cluster, third cluster, fourth cluster, and fifth clusters. I'll go ahead, change the cluster number here. It's a cluster number 1, 2, 3, 4. Same way here, we have cluster number 1, 2, 3, 4. S is basically size of the circle. If you reduce the size, number will reduce. My circle size will reduce as well. Changing the color here, let's say I'll go with pink, I'll go with blue, I'll go with yellow, I'll go with green. And here we go. We got the output here, which is exactly same as what we have seen here, this one. So here are the customers. Yellow ones are nothing but what? High salary, low spending score. We can check that. Yellow is basically cluster number 3. Cluster number 3 is high salary, low spending score. Perfect. Red ones are what? Red ones are nothing but cluster number 0. That is ASAS, average salary, average spending score. Makes sense. Pink one is high salary, high spending score. What is the cluster number 1? Cluster number 1 is high salary, high spending score. Looks good. Blue one is nothing but cluster number 2. Low salary, high spending score. Absolutely. And finally, the green cluster, cluster number 4, is low salary, low spending score. And that is also looking perfectly fine. So that is the idea. We created the cluster and it is giving me a good information. And from here, we have solved this problem. And as a whole, the benefit business is getting is reducing the marketing cost. If I am coming up with very expensive product, I cannot market more than 50 customers. Then I can create the cluster. And you got 39 customers out here. So I can market 39. I have the budget. That is perfectly fine. So I reduced my marketing cost. At the same time, I am very much highly confident that these are the folks who will definitely purchase the product, or the chances are high because they are having high spending score and salary is also high. So if I target these 39 customers, I have the high probability. Let's say still I have some budget, I can maybe target these folks as well because their spending score is high, salary is obviously low, but spending score is high. So that is how it works. I hope this makes sense to all of you. As I mentioned, with 1 hour of session, I tried my level best to give you the best idea how it works. But again, it's a big mathematical concepts, which we are covering more in detail in our curriculum of 9 months. And here we are discussing each and every concepts of machine learning, data science, and a lot of cool stuffs. Can you show new? Here we are not creating the new customer. Again, it's an unsupervised machine learning technique. In unsupervised machine learning technique, what we do is we are having the data set and we are going ahead and creating the cluster on the existing data. And now if a new customer comes in falling here, he will obviously be the candidate for the marketing. Prediction for the new customer will be for the supervised machine learning technique where we have the regressions and the classifications. All right, so I'll just ping you one more time the link. If you guys are interested on the data science, masters in data science or masters in data analytics course with us, you can fill up this form and we'll get back to you. How it will work in medical industry? It depends. For example, corona patients. Let's say there are a lot many corona patients coming in. And now I want to create a cluster from where I am getting the majority of the patients. So I can create a cluster on that based on the gender, based on the density of that location, based on the maybe the age group, right? So based on the various features, we can create a cluster. Let's say in one hospital, I'm getting a lot many patients. I can get the information of the patient and try to create the cluster and try to understand from which location I have the more number of patients coming in. If there are more number of patients coming in from the particular location, then I can say that, okay, this is the zone which we have to take care of, something like that. Same way, it's just a simple example which I have given. Same way, there are like huge use cases in every industry, whether it's a medical, whether it's any other way of industry. K-means is an unsupervised machine learning technique, absolutely. Any other questions? How to scale data example if you want to consider 2 to 5? How to scale as in? If you want to take age also is what you are saying. In that case, you can go ahead and here write 2:5. You can see we have 3 columns coming in. And then I will go ahead and create the clusters using 3 columns. You can see we have again maybe 6 clusters can be the best number of clusters. Here I'll change the cluster to 6. And here is the final number of clusters. And here is the output coming in. I cannot create the visual here because it's a 3-dimension. But yes, my cluster got created. And here I have to basically go ahead and take the output. And then we have to understand the pattern. It's low salary, low spending score, but we have created 6 clusters. So we have to check because age will also now come into picture, right? So I have to rename this guy based on understanding how it is. Like age also coming in, right? Here I have just taken low salary, low spending score, but age will also come into picture. So that we have to see the pattern and we have to rename it. What is the difference between k-means and k-means plus? K-means is an algorithm. K-means plus plus is a technique to initialize the centroids using k-means algorithm. So there are actually, if you go back here in the k-means documentation, k-means and random. So k-means plus plus is the select initial clusters or centers for k-means clustering. It's a smart way to speed up the convergence. Again, as I mentioned, these are a lot many concepts which I am not covering as of now, but this is the technique to make the smart selection of the centroid. Okay. How to standardize? If you want to standardize, you have the sklearn package. So for example, here from sklearn dot pre-processing import standard scalar, and then let's say sc underscore x is equal to standard scalar sc underscore x dot fit transform x, and x is equal to, here we go, I have the standardized data. Just 3 lines of code and we are done. My data is standardized. You can see here. It's no longer that integers coming in. Once that is done, you can proceed and go ahead and create the clusters. Okay. So scikit-learn is an amazing package which gives me a lot of things. But again, in our curriculum, which we are covering more of a mathematics, what's going on at the back end. You should be aware of what's going on in the backend. Running code in Python is not a challenge. You should aware of what is k-means plus plus, how it works, what is n init, what is max iter, what is tolerance. All those things you should aware of, and that is what we are covering in our curriculum. I pinged you the link again. If you are interested, you can use this link, and we'll get back to you on that. Right. All right, so that is what I have. I hope you enjoyed this session. We are done with this session, and basically this is the last session for this year. We are keep continuing the session in the next month as well. That is year 2022. And yeah, have a nice year ahead and all the very best for the next year. Going to fit and transform method out. Fit and transform is optimal, absolutely. I don't want to do fit separately, transform separately. I can go with the fit transform directly. Can you please explain in high level how to approach for any ML problem? How to approach is basically we have to get the data, we have to understand the data. Very first thing is understand the business problem, what they are looking for. Once we know that, we have to check what all information we can get from the business, which all things are important for me. For example, let's say I was working for one of the companies, one of the clients, TVS Credit. So they have their collections. So basically they have purchased it's basically NBFC, and they are giving loans to the various people. And many people are not able to pay the loan back, right? So then in that case, NBFCs will have to go and do the collections that give us the money back, or it's a TVS credit. So basically they are giving on the vehicle loans they are giving, so they can take the vehicle of that borrower and all those things they can do. But basically the idea is they have to collect as much as fund as possible, and based on various different features, they wanted to know that how much collection will come in. Let's say how many time my NBFC's employee going to the borrower's house asking for the money, and what is the age of the borrower, what is the gender of the borrower. Lot many different features are there. So we are understanding the data. Understanding the data is one of the important things. Understanding the business process is one of the things, and from there you have to go ahead and first do some data cleaning if required. After that, you have to go and try to understand how the data is, understand the pattern in the data, because it's a regression problem. So maybe we can apply linear regression, or various different techniques are available like decision tree, random forest, support vector machine, and so on. But again, we have to first do the data analysis, EDA, which is exploratory data analysis, and try to understand, do we see any pattern, do we see any linearity or not? Based on that, decide the number of features which are important to predict the collections. Once that is done, then we have to go ahead and check statistically also how things are, what are the p values and all different concepts are available. And after that, we have to create the model. We have to run multiple models. We have to check which is giving me the highest accuracy. And again, we have the concept of cross validation. So a lot of other techniques will come into picture. But the very key information is understand the business. Understanding the business problem is very important. And that takes a lot of time because data they are capturing from various different data sources, and we have to understand which all things are important for us to actually create the model. So getting the business information, getting the business requirement, and understanding the data is a time consuming process. Then obviously EDA, data cleaning, is the another step which takes time. Running the model, as I mentioned, it's not a challenge. Call the package, you are done. But what's going on at the back end is important, which you should aware of. And that is what as a true data scientist you will able to aware of, right? So that is the idea, and I hope this makes sense. We'll see you again next time. Take care and stay safe.